Welcome back, everyone. Now, if you've been a long-time viewer of my channel, you probably have noticed a slight format change. In the past 2 years, my videos have been primarily centered around the responsibilities of home ownership, cats, and off-camera, my lovely girlfriend. But as of right now, we I haven't really been in a position to make a lot of computer videos because it's just not really been, and my allergies are killing me. This might help. Ah, man, I was just out seeding the lawn and God, I think I kicked up some cosmic debris. Oh there, fella. Anyway, what we have here is a Massport rototiller. This is a baby rototiller. This is one that we use for the garden. I've used it twice so far. This actually belongs to my father, and I'm just sort of keeping it here for him for now. Let's take a look at this thing. It is beat to absolute within inches of its life. He got it used, and I've been using it, and he used it, and it's freaking used. The handles are bent. It's not missing any parts. It really, in this model, there was never a guard here or anything like that. It's got this heavy weight. It puts weight on it for weight purposes. Anyway, it has an old Briggs and Stratton motor. This is the Briggs, the Easy Spin. This is, I think, a points-based ignition system in this one. I'd have to look at the production date on it to see how old it is when we're filming it. The reason why we're filming it now is because it doesn't start without assistance. In fact, for as long as I've had this here, actually for as long as my dad's owned it, it just doesn't start. Put a full choke, full tank of gas, it just doesn't want to freaking, you get the idea. It doesn't want to start. But if you put a little bit of that magic juice in the intake, I've run out of magic juice, so I'm using everything I can find that's flammable. I think I've used intake cleaner, carburetor cleaner, brake cleaner, well, the old-fashioned flammable stuff, but I don't have any of that anymore. But it will start, and it will run like a dream. It runs absolutely perfectly. But, and it starts right up again. Shut it off, park it for a couple minutes, starts right up. It's the strangest thing. I've never had an engine that did that. Usually, it's all or nothing with these engines. This has a very old Briggs and Stratton stick carburetor. These are the old suction carburetors. I used to love working on these when I was a kid. It's got a giant air filter that is in desperate need of replacement. It's got this rubber seal here. You got this. This is where your choke is. Now these stick carburetors, they would choke. Now if they didn't have a throttle hooked up to them, you could just pull this out right here. That was your choke. My mini bike, when I was a kid, had the same carburetor. It was a much older version, but same basic carburetor. We haven't messed with this thing because it does run, and you can start it. It just takes a little effort. I bet the gas looks pretty clean. There's no cloudiness. So with ethanol fuels, if you look in the fuel tank, if we see any cloudiness, then you've got water in your fuel. But this one's pretty clean. So the carburetor is definitely probably going to need a cleaning. We're going to pull it apart. We're going to have to order some parts. We're going to have to order a carburetor gasket set, because these gaskets are so old we can't reuse them. We're going to give the carburetor a thorough cleaning. We're going to put it in the ultrasonic bath and see what we can do. What I expect to find is that the the main jet is clogged just enough to prevent it from starting. But once it's running, once it's started, it's fine. The engine sounds okay. It doesn't knock, but it does have a lot of engine wear, and it has a lot of oil leaks. I suspect that the front seal is leaking, and that oil is dripping around the block and collecting over here. Let's take a look at the oil level. On these old Briggs engines, they didn't have dipsticks if the plug was down on the sump here. Now, I changed the oil in this thing not too long ago, and it's still pretty clean. This thing hasn't been run much in the past couple of years. I would just run it for maybe like 2 hours a year at the most, between me and my dad. So one of the joys of working on these old Briggs engines, as I've done, ooh, there's a big one. Anyway, one of the joys of working on these old Briggs engines is they're just so easy to work on. Now on this one, you actually have to pull, so on the Briggs and Stratton lawnmowers that have suction carburetors, you can pull the whole tank and carb assembly off as one unit. On the horizontal shaft suction carburetor, stick carburetor they call them, you've got to take the tank and drop that first. So I'm not going to use the clown screwdriver for this. I'm going to use something a little more reasonable. I just pulled out the clown screwdriver because it's funny. It makes me laugh. And I like things that make me laugh. Okay. So, what do we got? Now, everything's all caked in grease. We'll just take these screws off here. We'll drain the tank when we get it off. Look at that one. Now, this has a tie down for the breather pipe here. Disconnect that. I haven't had one of these engines apart since I was a teenager. No, I'll better you that. I haven't had one of these apart since I was about 12, maybe. Because after I turned 12, my parents started making more money. And, rather than keep old equipment alive, my dad just started buying all new stuff. Bought a new lawnmower, a new snowblower, weed whacker, all that stuff. So I haven't really had to do much engine repair. But when I was a younger kid, when all my friends were collecting Pogs and playing Pokemon and shit, I was hanging around the weird old neighbor next door, who wasn't really that weird or really even that old. And I was working on lawnmowers because it was fun. He had some pretty. He worked for the local town dump, and he would drag home equipment. I've talked about him before on my channel, and I've bought equipment from him before. Later on in life, I bought a used lawnmower from him once when I needed one for a place I was living at, and I kind of wish I kept it. Actually, it was a nice old 1988 Homelight, aluminum deck. Had the Briggs Quantum 3.5 horse engine on it. It was a nice machine. Is there another screw? Oh yeah, okay, there's a bracket that anchors it to the block. That's gonna be let's see what size that's gonna be. Probably 10 millimeter. No, 3/8. The Briggs, not a Honda. Let's see. Probably this guy here. It's 3/8. I don't use my 3/8 much these days. Everything I work on now is metric. But I digress. So I would take, old junk lawnmowers that he's got kicking around and make them run again. Oh my. There was so much crap on that bolt that wow. It looked like it was a 3/8. Now, I don't have anything smaller than a 3/8 in the socket over here, because... Oh, wait a minute, I do. I do. Over here, on the other side of the toolbox. There we go. I just need to get an adapter. There it is. Now we're cooking. Junkyard John, or whatever the hell I called him. My dad called him the Lawnmower Man. Forrest Gump. He was an eccentric dude. A very interesting dude. I still talk to him, and only these days I've actually helped him fix things because he just either doesn't remember how or can't figure it out. And good guy. Come on, what the? I am so bad. I used to be able to look at a bolt and I would know right offhand what it was. I don't know why I can't do that anymore. Is it old age? I'm only 35. What the fuck? What size? Is that metric? So it looks to me like this bolt was added years later. It is metric. It is an 8mm. You've got to be shitting me. It's an 8mm. Somebody's had this apart before. Interesting. Okay. Got it. Man, that was a freaking nightmare. Junkyard John. What a guy. Alright. So, now we're going to drop the tank. Drop the tank! There, I don't know what that was supposed to be, but... Oh, the wheel's in my way! No! Son of a Brachiosaurus. God damn it. I should have drained it first. I didn't realize it was completely full! There we go, got it. I didn't break the pickup stick. Although... Yeah, okay. So we got a full tank. Ah, yes. Look at this. Let's see if we can get this on camera. There is schmutz in there, and that is bad. But the surface is clean. There's no corrosion. And the gas is still good. I'm going to dump it. I'm going to filter it, but I'm going to dump it back into my big gas can. All right, so we got all the fuel out. The fuel that came out looked okay. I filtered out all the smudge. There's a little bit of water in there. Now, that's going to happen with ethanol. You can see now that I got it moving around, there's some cloudiness in there. That's a combination of moisture and possibly just sludge. So we're going to clean this out. Now, you might be wondering why I dumped it into a perfectly good can of fuel. Because it'll dilute it, and I can't dump it anywhere else. I can't mix it with my oil waste. I don't want to contaminate that. You can't dump it in the ground. I can't burn it. It's got to be... That's how I get rid of old fuel. I mix it with good fuel, and I run it in the lawnmower or the leaf sucker thing or whatever, and it gets rid of it pretty quickly. As long as there's no crap in it, there's no debris, and it's not loaded with water, then it's okay. At least that's how I've always done it. I could be, off base here. So let's put this aside for now. They're starting to get kind of dizzy here. Some fumes. We're going to blow that out with the air compressor. That's how we're going to clean that. We're going to get the rest of the liquid out of it. And we're going to just blow it out with the air compressor. Now let's take a look at this carburetor. So to get that out, I'm just going to take our Phillips head screwdriver, and these bolts are kind of at an angle. That's why they're slotted. These old Briggs engines. I really loved Briggs engines. I still do. Actually, no. Let me take that back. I don't like the new ones. I got a new lawnmower. If you saw my video on that, it's I bought a Toro with one of the new Briggs motors in it. It's one of the ones designed for vertical storage, and it is not. I'm just going to come out and say it. It's not a good engine. I don't recommend it. I bought it because, you know, I got a really good deal on it. I wouldn't do it again. Honestly, we've reached a point where the Chinese build better engines than we do. And that's just sad. Okay, so right off the bat, and I suspected this would be the case, but the pickup tube screens are a little clogged. Let me get that in focus here. Oh, there we are. Yeah, these were a little bit clogged. And they are plastic on this carburetor. This is an older carburetor. Sometimes they develop leaks on the pickup tubes. I've had that happen at least once or twice. This gasket, as bad as it looks, where the hell is the lens? There it is. I could reuse this, but I'm probably going to just... You can see it's been leaking. It's definitely been leaking. This gasket is no damn good. We're going to have to try to find a new one. But we're going to just spray this down. We're going to clean it up with... I'll see what I have for cleaners. I don't think I have much right now. And we'll take a look at the needle valves. We'll drop it in a ultrasonic bath, and we'll see what happens. This comes off. This is bent. I'm going to try to straighten this out. See if I can find a way to do that. Throw it in the... Yeah, I'll figure something out for that. Let's take a look at the diaphragm here. Let me clean this up. This is gross. Let's just clean this up. Okay, take a look at the tank. It's all clean now. I'm finding that there is no rust in the tank at all, which is miraculous. But there is a little bit of rust in this chamber here. I have to re-look up how these carburetors work because they're a little different. Okay, so I'm reading up on it now, and I've read this article years ago, but it's the Briggs PulsaJet horizontal carburetor. And that looks like what we've got here. Let's compare the photos. Threaded intake flange holes. Does it have that? They don't appear to be threaded. Oh yeah, this is a different animal. Yeah, I'm looking. So, all right, so that's how it works. So there's a fuel pump here. So the fuel is drawn from the bottom of the tank through this straw. This is a vacuum actuated fuel pump. And it works in a similar manner to the fuel pump that you'd find on a motor scooter or a motorcycle that has a fuel tank that's lower than the intake or than the carburetor. So it sucks the fuel from this tube here, and this tube here is where it's drawn from the main jet. Here's your main jet right there, and that's where it's drawn into the Venturi. But we're going to drop this guy in the ultrasonic and see what happens. I'm going to make sure that I don't lose any of my hardware. Let's take the needle valve out. Let me see where it is now. So I've been asked this before on whenever I work on an engine of any kind. What I'll do is I'll see where the needle valve, if it runs good. Otherwise, I want to see where the needle valve is right now. So we're gonna use the screwdriver here. We're going to use this as a reference point, this side, or one side of that. Okay, so let's see. It's one, complete turn. Two, one and, shit, that was like 1 1/8 turn out. So now we know how far in it was. We know where to start. So I'm going to pull this needle valve out, and let's see what horrors lie within. Oh, wow. It's in remarkably good condition. This thing is clean inside. It's not dirty. It's not clogged. It's not... So what's the problem? I think it has to do with the fuel pump. I think the fuel pump is draining back all that fuel back into the fuel tank, and it's siphoning it out. And as such, that's really what's going on. It's losing its fuel. So you could pull it all day long. It should refill the, but it's not. So the fuel pump is weak. So this too long didn't read. Here's what's going on. The fuel pump, this diaphragm here, is bad. It's weak, and it's not allowing the fuel to pump correctly when you're just pulling it to start it. Which is why once you get ether, magic juice, whatever you want to call it, once you get that stuff in there, it wants to live. It runs perfectly fine because there's enough momentum there to draw the fuel out. And yeah, so I think we can fix her up pretty easily. So we're preheating our little machine here. Now, one of the things I want to point out, this is a Harbor Freight ultrasonic cleaner. This is the biggest one they sell, and it's still quite small. Further than that, it has a little flaw. Oh, there it goes. It's making heat. So one of the flaws is they don't seal these from the factory along the top rim here, so water can go around and contaminate the control board. Just FYI. So we're going to set this to its maximum 480, and we're going to start it. Oops, what did I do? I'm going to let it... Now what we're using for cleaner is this stuff here. This is Harbor Freight's own ultrasonic cleaning powder. We'll see what it looks like when we're done. I've used this for another carburetor before, and it worked okay. You'll see that anything that we didn't get off of it will start to dissolve into the fluid, and it'll get really dark and black and gross. So let's check out this intake port. I should probably pull the head off this guy and see what the hell's going on. Intake port looks pretty good, pretty clean. Oh, I hear the fan kicking on in that thing. So yeah, we've got a leaky, definitely a leaking, or clogged, possibly even clogged, who's what's it. This is the crankcase ventilator. So that's probably completely clogged. But oil is coming, that's crazy, it's going everywhere. So it's possible that we could have a leak in the, both the flywheel side and the business end crankshaft seal. That's not a good thing. But unless it's a two-stroke engine, it'll still run. A two-stroke engine, you can have these defects and it won't run at all. It'll run lean, if at all. But a four-stroker, it'll run. Let's take a look at the spark nut. It's a reference, by the way, to my favorite TV show of all time, Third Rock from the Sun. I love that show. If you don't get the joke, nod and smile and move on. We're gonna. Gap is it doesn't. I don't even think that's the right plug, to be honest. We're gonna have to look up and see what the right plug is for this engine. Get a new one. It's kind of ashy. It's not like it's burning a lot of oil, though, although it does kind of look a little black. So, but it's not brown. But it's got a lot of shmoo in there. We're going to get a new plug for this guy. I don't know which one the right one is, so I'm going to have to look that up. Let's see, what does the top of the piston look like? Let's see if we can't... I've got a boroscope thing. Let's take a look. There we are. You can see the cylinder wall. And a little bit of carbon. I'm gonna actually look at it myself, and then I'll see anything funny, I'll point it out. A little bit of scoring. Actually, a lot of scoring. That's a lot of light scoring going on in there. And it almost looks like it's wet, which is kind of funny. Yeah, okay. I think I've seen enough. This poor engine. It's not like there's any gouging going on, but there is scoring all along So you can't even really see the cross hatching anymore. That's a thing of the past. Its best days are behind it. Look at this. Yeah, this engine's toast. Let me see if can you guys see that? Yeah, this thing is absolutely toast. I can see. Can you see? Trying to get two cameras to all vertical scoring. So yeah, this engine's definitely had it. That's a shame. But it doesn't mean it doesn't run. I mean, I gotta be honest. You know, it puts out enough power to do the job, even still. Despite all this, you know, it still puts out more than enough power, you know, to kill the garden or the lawn. So, I mean, well, the engine's definitely toast. Let's get a compression gauge on there. All right, so we're going to get the compression gauge all set up. In order for 87 octane fuel to, in order for an engine to run, period, you need a bare minimum of 90 psi. So we're going to see, you know, just how far off this engine really is. So I'm going to hook up my compression gauge. Now, normally you would open up the throttle plate all the way, and you would remove the fuel source if there is one. And we're going to pull the starter rope until the gauge stops moving upward. So I'll get that in focus. There we are. Now this gauge isn't 100% accurate. It is a low end gauge, but so we're gonna fell off there for a second. All right, let's see where we're at. Oh crap! Yeah, we're below 90 pounds. This engine is it is a good running engine. I just tilled the garden with it. It does run, I swear to God. But it is way below spec, even for, this engine needs a rebuild. And because the piston walls are so badly scored, I don't recall if this is one of those Briggs engines with the, there was a certain, the bore was coated with some kind of a material, and they cannot be honed, nor can they be bored out, as far as I know. So this is not an engine we're going to put a lot of money into. We're just going to do the bare minimum to get it running again, reliably. Now, it is possible, and I just thought of this, that part of the reason why it will run without being first warmed up with ether is because the compression is so goddamn low. So what we're going to do now is we're going to put a little bit of motor oil in the bore, and we're going to do a second compression test. This is going to confirm whether or not we're losing compression. We know it's bad rings. I mean, look at that bore. Are you kidding me? But we're going to do the compression test again by wetting the cylinder or the piston top and the rings. And if the compression goes up, then we know the problem is due to faulty rings. If the compression does not improve, then we're looking at a possible valve issue. And the valve issue is very easy to resolve in this engine. You basically pull the valves out and you grind and lap them with a lapping compound. So we're going to get that oil spread around the bore, and then we're going to put the compression gauge back in and see what happens. Okay, I'm already seeing a difference. We gained a little bit. We gained a very little bit. Probably a good 5 pounds. Okay, the water's blacker than the ace of spades. And hot as hell. You can tell it's definitely doing its job. Alright, so I just popped onto eBay and I ordered all generic parts. I'm not going to spend the money on the real stuff for this guy. We got a new air filter. We got a new carburetor kit. Now, the way they sell the kits for these is they include all the parts for all the variants of the same carburetor, so we should be good to go there. And I actually did not go OEM. I believe it or not, it's so not like me, but this machine is borrowed, first of all. Secondly, it's, you know, something that we use once a year, so I'm not too concerned. So I got a $2 air filter and a $7 carb kit. I'm pretty happy about that. Even the gearbox in the front is leaking, and there's a little, we have to pull this weight off, but we can add oil to it, and it's held on by a nail, a bent nail. I wonder if that's a factory part. Oh boy. Yeah, there's a lot of bending and not a lot of turning going on here. That makes me quite nervous. I have a thought. I have a thought. Not a good one, but I have a thought. And it just might be dumb enough to work. Hear me out. Hear me out. Okay, so we've got our extension. It's a 3/8 extension, straight through 3/8, to a 10mm socket, to a 10mm 6-pointed thingy, to a ratchet. Okay. Now, it works. Here we go. Here we go. Don't break. Ooh. Satisfying. Okay. Alright. What, if anything, is in there? Now there's a magnet on this guy, so it smells like oil. Looks like oil. It has the consistency. There is a bleed off hole. Now typically with gearboxes, this is pretty much universal from what I've found. You've got a fill hole and you've got an inspection or drain hole in the bottom. And what we're going to do is we're going to crack that open and we're going to pour oil in until it starts coming out of that bottom hole. That's usually how these things work. So let's do that. But I don't have the right oil, unfortunately, and I'm not going to go buying it because I have that. And this thing gets used so infrequently that it's lucky it has oil in it at all at this point. So let me find a small pan. So maybe we can get this one with a wrench. I'll sure try. Ah, good. That one wasn't tight. Now this one also has a leak. So I bet you anything I put in here is going to wind up back on the floor, as is tradition. Okay, I got my Harbor Freight jack stands. Oh my. Oh my. This stuff is sludge. And I'm about to fall off the jack stand. Oh my god. Guys. It's no good. Alright. Oh boy. But one thing I don't see is metal. But of course that requires obviously a proper chemical analysis, which I will not be doing. Right there. And we're gonna put oil in there until it starts coming out the other end. That's how my mama fed me when I was a baby. There we go. Yeah, it's low, for sure. Okay. Oil dripping out the other end, as is tradition. And put a little extra in there. Just to make sure. Okay. Doesn't use a lot, which is especially one of those, you want to factor that in because it doesn't use a lot of oil, which means that if there's nothing, or if it's really low, then it's really low. So we're going to let that dribble out. And that stops dribbling out, then we can start torquing these down. So this was the fill plug. I think my dad said he changed the oil, but I don't think he did. I thought he said he did it, but I don't think he did. It's pretty obvious that it didn't get done. I could have sworn he said he did something about this. But that oil is, I mean, it is probably original 1981 oil from the factory. No doubt. No doubt. No doubt in my mind. So, let's tighten this sucker up. And we'll get the drain plug. I don't want to over tighten it. I'm going to do the same thing. I think it's done draining out. That's a little too much anti-seize. I don't need that much. But okay. This one we put in the wrench. The anti-seize is not necessary. I need to point that out. I just put it in there for good luck. Just so that it threads in nicer. Now, one thing that I love about Harbor Freight, these, just about every size of the rainbow. You might be thinking, why not put a Harbor Freight motor on this? You know, we actually talked about it. My dad and I did in fact discuss this. But because the engine still ran so well, there's no reason to. Good, I got one that fits. Drop that back in. Stick a pin in it and call it done. And we talked about either buying a new unit or just putting a Harbor Freight motor in this because it leaks so much, you know, oil. You know, it's almost worth it, but it's really not. So, you know, at least now, now it'll be able to run under a heavy load, and it's not full of maple syrup. Shit, that wasn't maple syrup. It was molasses. Who am I kidding? But yeah, it'll be able to till a little bit easier now without working so damn hard. Okay, so put these away. And in a week or two, I'll have all the parts to put the carburetor back together. Just in time for a project that I need to work on. I need to dig up some area in the backyard to do a put in a patio. And these are great for digging up, you know, packed earth, getting it all, you know, tilled. It's why they call them tillers. Gotta love these old Briggs gas caps. The EPA doesn't allow these anymore on new equipment because they don't have any provision for filtering out fuel vapor. And it was discovered that a good portion of the emissions or the hydrocarbons entering the atmosphere are from power equipment, lawnmowers, weed whackers, tillers, etc. Because they were built and designed long before any emission standards were ever enacted. So they were running too rich. Half the time they weren't adjusted properly, so they were running too rich or too lean, and they just were contributing such a huge amount to greenhouse gas emissions. But the fuel caps, that was a big part of it. So modern CARB-compliant fuel caps are designed, I believe, with a charcoal filter built in. And they don't vent like they used to. Little fun fact. When we come back, it'll be a separate video. We will be doing the, we're going to put it all back together again and see if it runs. I could have started it for you guys today, but I just didn't want to. You know, why don't we do that? Why don't we do that? Why don't we hear this thing run? Just to quell your inquiring minds. If you're still here watching, thank you. Okay, What am I going to use that will combust? What do we got? Anything? We got fluid film. That's not going to work. Sea foam's probably not going to work either. Hold on. I have a little bit of this stuff left. Just a little bit. Here we go. Almost. Let's try that again. Yes, you can run an engine without a carburetor. Did you know that? It really works. All right, here we go. Almost. Ooh. Well, it did start. All right, folks, let's talk a little bit about how the Briggs and Stratton suction carburetor works. But before we do, I was able to clean inside of this little pre-chamber here. And what I did is I used, I made sure it was completely clean and degreased. And I took some Evapo-Rust. I held the tank in a vise upright. And I filled the chamber with Evapo-Rust. And I took all the rust away. It's a little discolored, but that's okay. There's no rust in there. And that's all we care about. So, how does the Briggs and Stratton suction carburetor work? It's actually quite simple. So this particular carburetor, actually the way the Briggs and Stratton suction carburetor has a vacuum-operated fuel pump integrated into the carburetor body. On the horizontal shaft engines, that fuel pump is mounted right here on the side, right near the throat of the carburetor, or the intake side of the carburetor. So how this works is, all right, the principle of how a carburetor works is it uses the air velocity to draw fuel in from from the fuel inlet. On this particular carburetor, it's this smaller tube right here. And the fuel flow is regulated, or the mixture is regulated by a needle valve that goes in here. Our throttle plate is right here. And if you look at where the throttle plate, the fulcrum is, or where the butterfly valve would be, it is right in line with the main jet, which is what this is here. Now there should be an idle jet in here as well somewhere, or a high and a low speed jet, but I think this is a single jet actually, or a fixed jet carburetor. So this does not have a high and low. It's just one jet in the whole carburetor. Very simple design. So you'll notice that, so this part of the carburetor is called the venturi. This is where the air and fuel are introduced to each other. And they're drawn through, on the intake stroke, they're drawn through a spiral, kind of a spiral device that causes turbulence within the mixture. It causes it to, well, spiral. It creates like a swirling motion as the mixture enters the intake port on the engine. Are you with me so far? So the magic happens on the suction carburetor a little differently than on a float carburetor. The suction carburetor does not have a float with a gravity-fed fuel supply. No. The suction carburetor actually pulls the fuel from below. And it does that through the use of a vacuum-operated fuel pump. And that is what separates the suction carburetor from the float carburetor. So on a suction carburetor, on this particular style, you've got your fuel pump right here. And how that works is quite miraculously simple. So what it does is it draws vacuum, or when vacuum is drawn through the carburetor on the intake stroke, it causes a small diaphragm that's mounted right here. It causes it to retract into the carburetor body. Now, the cover that normally goes over this fuel pump here has a small chamber, and that's where the fuel is drawn into. The fuel is drawn in through this port on the top here, which, if you look at how it's drilled straight from up here. So imagine this carburetor is on the machine shop floor, or on the machine. They run a drill right through here to this point, and then they run another drill to this point, and they stop it when these two holes meet. And that's how they create the passage in the carburetor. In fact, that's how most carburetor passages are either created or fine-tuned in the machine shop when they're built. They just run drills straight through like that. Anyway, and then they put Welch plugs wherever they don't want there to be an opening. So, anyhoozles. So, there are two check valves. And I'll explain how they work. So the check valves are basically a flap of gasket material. It's like a I don't know what the hell it's made. It's like some kind of a fuel resistant rubber. Not sure what the formulation is, but the check valves are basically just little flaps of rubber that cover the port in one direction and then open up in the other direction. So as that little diaphragm is being pulled in on the intake stroke, it draws a small amount of fuel by opening up the flap on this port. And then once that fuel enters the chamber and the vacuum is stopped, the spring that's behind that little diaphragm causes the diaphragm to push out. So it pushes out by opening out the flap on this port. And then it sends the fuel across the carburetor body to a little tiny drill hole right here. You can see it right there, a little hole right there, where the fuel is then deposited into this chamber here. Now this chamber is a much smaller chamber than the rest of the fuel tank. It makes the fuel easier to access. It takes less vacuum for the carburetor to draw the fuel from here than it does from here. Now remember, this particular engine came with at least two different fuel tank sizes. This is the smallest of the two. I think it's like 2 pints or something. But there is a bigger tank available for these engines depending on how the equipment is put into use. So you could have a much longer runtime. And that's where that effect really comes into play, because for it to draw, so let me put it out to you, lay this out for a sec. For this engine, for the vacuum to draw enough fuel for an intake charge of air and fuel mixture from a deep fuel tank, it would take a lot of vacuum. So that's what this design is all about. It takes less vacuum for this carburetor to pull fuel from a tiny little chamber here than it would be from the full tank. But we're not done. We're totally not done. And my cats are scratching at my carpets. These sons of... Anyway. So that's how the fuel pump works. Now the intake, or the fuel inlet, is right here. And while it's drawing fuel or drawing vacuum, allowing this fuel pump to do its job, it's also drawing the air-fuel mixture through the carburetor's choke, or the air filter that goes here. It draws the air through, and then it creates the Venturi effect, which is it uses a low pressure. So this is a higher. So all right, from this point, let me explain this. So from here to here, it's atmospheric pressure. But from here to here, it's below atmospheric pressure. And that causes a suction effect for the fuel to be drawn up through here, through this needle valve, or I'm sorry, through this needle valve, into the Venturi. And then it mixes with the air through this little interestingly designed spiral device. Now, looking at it closely, it's pretty obvious that the spiral device, let me see if I can get a better light on here, it actually deadheads. It looks like it's divided. You've got what looks like 2 intakes rather than 1. If I could, I should probably take the choke completely out of here. We can get a better look inside. as to what it looks like. But if I recall, I've had these apart before. That spiral goes all the way into the Venturi. So it's now this is a very simple. Let's see if we can use the camera to see. See if you see the moving choke here. Yeah, you know what? It looks like it deadheads. It looks like there's two different ports, like one separate port for the intake vacuum needed to run the pump, and then a separate port for the mixture. And I'm looking down the barrel of this thing, and it's kind of hard to tell. No, it does go all the way through. It definitely does. Yeah, I think it does. But anyway, that's basically how these work. It's a very simple design. They're very reliable, very easy to work on. Now this is, I believe this is the earlier version of this carburetor. The later version had check valves that were cast into the pickup tube, which was part of the carburetor casting. And that's where they put the check valves. I don't think they were here. They were down in the tube. And yeah, and these tubes are replaceable if they snap off. You can buy new ones. They're not terribly expensive. I believe they're actually glued in. But that's how it works. So, not a great carburetor for your mini bike or your go-kart probably. They actually have special designed, I believe they're multi-jet carburetors for those types of motorsports applications. But these are really good for running at one speed and one speed only. That's where they shine. Anything beyond that, and they tend to ask me how I know, right? I had one on my mini bike, and you know, it never really ran right. They don't like to be jostled too much. They're not adept for that kind of application. So I hope that explains it. Till then. So in our next video, we're going to be talking about putting this thing back together again. We're going to get it totally rebuilt, and we're going to get it back up. I'd say on the road, but, well, it's not really a road-going vehicle. But we'll have it back up and running, I hope. Looking forward to that. And I can start tearing up the yard. Well, I'm not really doing that. Not right now, anyway. But I got to clean this up a little bit better, so that's what I'm going to be doing for the next couple of minutes. I'm going to clean this off, clean the rest of the gasket off with a real razor blade, and hope for the best. So once you get once you get the gasket material off of here, you can polish the surface up by progressively sanding it, you know, with your finger. You don't want to take too much material off, but we got some 1500 grit sandpaper. We're just gonna kind of clean this up a little bit. We don't want any leaks. We're not using any gasket tackifier or any sealant. You don't want to use sealants on these. That's bad news, bears, man. Don't do that. There's no need for it. If the surfaces are prepped right, you won't have a problem. But before we go, and we move on to our next video, which will happen once I get the rest of the parts, I want to talk a little bit about the... now, this design is very similar. It's a much more modernized version of the carburetor that was on my 1934 International Harvester LA engine. Once upon a time, I inherited my grandfather's his antique engine collection, which consisted of 3 engines, 2 International Harvester LAs, 1 running, 1 not, and a Briggs and Stratton horizontal shaft engine from the 40s, which I still have. It's at my father's house, or my parents' house. Actually, I told him he could take it over if he wanted to do something with it, but so I had this antique engine, and I had nowhere to put it. It was nothing I could use it for. I didn't have a house. I lived in a condo. So I gave it to my dad, and then my cousin decided he wanted to take it over, so I gave it to him, and he ended up, I think he sold it, which I wasn't too happy about, but actually I was quite mortified when I found out that he got rid of it, but nevertheless, the carburetor on that engine was very simple. It was really just a Venturi and a fuel port and nothing else. And it used, now that engine produced a lot of vacuum. It was a massive 1-cylinder engine that only produced 3 horsepower, 2.5 horsepower. give or take. So it used the massive amount of vacuum that that engine created to draw the fuel all the way from the bottom of the fuel tank. And then it had a check valve at the foot of that. It was just a copper tube, and there was a check valve at the end of that. So the fuel would be drawn up a little at a time until the engine started. And then once it started, it was pretty much good to go. Now the check valve that was in the engine when I got it was completely rusted out. And the closest thing I could find, I desoldered the check valve cover it was soldered to the fuel line. The closest thing I could find was the detent, a little stainless steel detent that was used in a Datsun dome light from a Datsun 510 or something, whatever. It was in my dad's parts bin, and that little ball bearing worked perfectly fine for as long as I had the engine, and God only knows what happened to it since. But anyway, that's a nice clean surface. That's not going to leak. And the surface on the fuel tank, I mean, we can run some sandpaper over it, but I'm pretty confident we won't have a leak there either. So here's to a nice tight seal. Real quick, once you clean the fuel tank out and you get any rust. Now, if there's no rust in the tank, you're okay, because that means the galvanized coating is still intact. But if you happen to have rust, like in this little pre-chamber here, you've got to prevent flash rust. Once you get the rust out with evaporust, you've got to wash away the stuff. You can't just leave it in there. So you have to clean it out. I use hot water and a little bit of degreaser, cleans it right out. But then you've got to immediately dry it, and you've got to get some kind of a oil or something in there to prevent it from flashing over. So I've been using WD-40, but you can also use two-stroke oil. Take a little bit of two-stroke oil, mix it with some gasoline, and slosh it in there. And that'll prevent it from flash rusting. I just want to point that out. So anyway, when we come back, oh my. Looks like this is, I just noticed, it looks like this was added later on, this little bracket here. Oh shit. That was added, that's soldered to the tank, probably by the OEM, the company who made the tiller. And it's made of brass. What the hell? No, it's not brass, it's coated. It's electroplated in brass for some reason. And they soldered it to the Briggs tank. That's kind of funny. I just noticed that. Well, till then. Till then, get it? Till then? Anyway.